All right, this is a video for the actually it's not the first part, the third part, the what do you call it? The blade. Okay. Yep. So let's see the parts you'll be making this, and this is mainly two parts. One is a extrude, and then the second one is a big swept. Okay. And once you finish this, you should be able to get a preliminary assembly because this is symmetric, so you can just have two exactly the same parts and reflect to the other side, and that'll give you an idea. Okay, and before we start, I'm gonna emphasize on one thing. Although I did say the dimension doesn't matter on your part, but in this case, okay, the swept is very picky on the dimensions. If your sections are not good, um, or they don't align well, your swept would fail. Then you need to really follow the dimension in the slides. Okay, so enough said. Let's start with new file. Let's see, model. I just put on the desktop. And okay, so a blank file. Let's turn off the assembly. Let's leave one. That's the slides. Okay. So again, we're gonna start with a sketch on XY plane. Okay, and let's see the steps. Extrude. Then we made a cut to get this sort of a step. Then we made this face a little bit tilted. It's called draft. Then next we go for the swept. Those two are the guide curve for the swept. Then we made seven datums. Why so many datum planes? Well, um, I need that many to get this shape. Okay, let's say that. I tried three, but they don't comply well. Then okay, so we're gonna put seven sketches on the seven datum plane. Then we do the swept. So that's the major steps, and in between we have some edge blends. Okay. All right, so that's the sketch for the extrude, and we need to zoom in a little bit. Okay, so again, the sketch. Start with circle on the origin. See, we have a smaller circle is 0.31 in diameter. So that's small, just fit. Then the second one is well, this one, 0.56. Yeah, click. Okay, so next we could just use, whoops, profile tool. On the top, go down, then vertical. Then there's sort of a fillet. We can change that to arc. And that's another arc. I'm just going wild here. And arc, come up. Yeah, let's make a tangent. Okay. Then this is horizontal. Go straight up. The last one is an arc. So that's the basic shape, and this corner is, of course, tangent. Well, this is 12:30 in the morning, a.m. So I'm sort of dizzy a little bit. So those two are parallel. Yeah, so I'm adding constraints first. Then tangent, that's all good. Then notice the top point, we have a dashed line that indicates this point is on y-axis, and the same goes for this point. So what we got is point on y-axis. Apparently you can't pick that up. So geometric constraint points on curve. Then we have 2 points that goes on y-axis. So constrain them to y-axis. Okay, that's one thing. Then this apparently it should be concentric. Okay, those are mechanical parts, so most of the time they are always concentric. Then the angle is 30 degrees on the top from horizontal, so 30 degrees. And we have sort of dashed line here that indicates this point is also on the axis. So need to look for the shortcuts. So the shortcut is C. Okay, because it's hidden inside, I'll just use keyboard shortcuts. C, then point on curve on x-axis. Then I think that's all for the constraints. Then we're gonna start with the dimension. Vertical ones, 0.6, 1.91. So shortcut, keyboard shortcut, that's D for dimension. From this point to x-axis, well, you could click on the point, but it's better to click on your data axis, which is x-axis. So 0.6. Then from x-axis to, somehow I lost the zoom. Okay, from x-axis to where the center of this arc is 1.91. Yep, it's very out of the scale, so we can drag this point back a little bit, then drag this away a little bit. Then we have another circle here. Doesn't matter about the dimension. Vertical ones, then those on this side, on the other side, from this point to center of the arc. Okay, that'll be 1.1. Then from this little step to the center of the circle, 0.17, and drag this to position. Then we have I think we have all the vertical ones. Then we have 2 horizontal. Is between y-axis to the center of the circle is 0.4. Then from y-axis to this edge is 1. Okay, that's the horizontal and the vertical. You can tell the color it's changing, so it's constrained. Then if you feel this looks weird, we can add a constraint for the radius first. So add a dimension for the radius. Okay, now it's a radius because it's an arc, it's incomplete circle. That was diameter because I drew a whole circle there. So you can say 0.59 divided by 2, that'll be the radius. This is well, for this dimension, you have to match this dimension to the hole on the handle. And in the slides, it's actually rounded up. think it's 9/16. That's 5/16. Enter escape. Okay, so it's not. Maybe 3. Yeah, that's 3/16. If you use the 1.188 for your handout, then you can use the same info here. Okay, it really doesn't matter because it's not very structurally critical. And you're going to use the model we gave you for the finite element anyway. Radius 0.47, radius 0.34. Looks all green, fully constrained, so we're good. One more thing is this little line here. That's for the datums next to cut that step on this extrude. So we need a short line from the center of the arc to be on the arc. I think that was a midpoint. So yeah, it should not be a midpoint. Point on curve is good. Then we do have an angle here, 30 degrees. So somehow my keyboard is not working well. So 30 degrees, fully constrained, looks good. Then finish sketch. Now we're gonna extrude. The extrude is 0.27 symmetrically. So 0.27, hit enter. And here we're gonna use region boundary curve because we put all the circles in one sketch. So you want to extrude this part. You also want to extrude this part. Okay. Well, there's a lot of ways to make this little step here. I think this sinkhole. Anyway, this hole. You can do this in a slide in the way that slides did it. You can also do like this, and next do another extrude for this piece. So we know the bottom is minus 0.27 because that's a half. Then it goes up to, we have a number here, 0.17. So you got 0.1 inch for the top. Then we can do a unite to this piece. That's different from the slides. The slides is cutting the top off from the first extrude. Now we're extruding another sleeve inside the big hole. So either way, any way you like it. I think I forgot some fillets here, so we can go back to the sketch. We have 2 fillets, 0.05, so they're the same. Then we can just type in the radius first, hit enter. Then from now on, the fillets will be all the same radius. You don't have to enter numbers every time. Sometimes in the sketch, you want to take a preview how the extrude is going to change. There's your button, update the model from sketch. So it'll update the solid when you're in the sketch. Okay, and let's go down one more slide. That's the datum to cut this. Okay, to make a sketch to cut that. So that's the datum. We're gonna make a datum plane on the curve. I'm gonna change that to on curve. Pick this curve, and by the way, don't convert that to reference because if it's a reference, you can't pick that up. Okay, so the position actually doesn't matter because you're gonna extrude that sketch on the same direction. So as long as you can cover the whole solid, doesn't matter. To be safe, we just put it here, and I say OK. Make a sketch on that datum. If you like, well, you sort of have to change the sketch origin to this point. So let's see, that's a sketch. And notice my axis in the slides is different. If you do this way, you're gonna be careful of the picture, of the sketch. You have to pick the right side, or you can just double click and switch the axis. Okay, so that'll match the axis in my slides. Then we're gonna start drawing. So profile tool, something like this, then goes up. Actually, it snaps to the top. If you snap to this edge, you will not need another constraint here. So we can snap to the edge here, go down, then go about same place, and don't snap to anything yet. So better just to get away, draw things away from those symmetry planes. So they cannot snap to something you don't want to. And those two lines should be parallel, because this is a uniform thickness, or this sort of uniform thickness, parallel. Then dimension between those two, as you can see, it's 0.27. Then we have 2.1 inch from the y-axis. That's why you need to put the origin the same as mine. Between this is 0.1, and between this to that point is also 0.1. And notice my line is not snapping to the top anymore, so we're going to be the same as the slides. Okay, so the thickness of this is 0.27, and you want this line to be flush to the top. You can try to drag this point to snap to the top, but it's not working. Oh, it's working. Okay, that's one way. Let me redo that. Undo that. Then you have another way is put a constraint, collinear. The bottom line collinear to x-axis. Okay, and y, because this is 0.27, that's half of the distance. So either you touch the top or touch the middle. Okay, and here we want to make this distance centered. So center, that means midpoint constraint for this line to sketch origin. And this side is a little bit different, 0.26 D. Okay, keyboard. 0.26. Then actually that'll be enough for the sketch, as long as this goes outside of your solid. But sometimes you want fully constrained sketch, so we'll give you that. I'll give a big number or larger number, fully constrained. Then just extrude. So this time we extrude symmetrically and drag, as long as this can cover it. So that's an extrude and an intersect. So extrude, then here we need to get intersect. This will give us a profile like that, like this. So before and after. Okay. Now we can hide this vertical sketch. We can hide the datum. Next is what? Edge blend. Okay, we do need this edge blend because we need to make this edge tangent. So this is aesthetic, but it's also affecting the steps later. Okay, 0.1 inch. So I have 0.1 here. I have to change anything. 0.1 inch. Next is the draft. Okay, notice this face is vertical. This cylindrical face is vertical, and in the real thing, it's actually a little bit bigger at the bottom, or it goes outside a little bit at the bottom. So that command is draft. Let's see where that is. It's all compressed inside. Okay, draft. You can tell from the symbol or the icon. Okay, so specified vector, it's the angle from which vector. So you can just put it on Z, okay? And the stationary face is top face. And this face will stay the same. Then the face to draft will be this face. And the angle is 15 degrees. Let's then hit enter. And you can tell from here all the face on the edges. So 11 faces, we don't want that. We just want one face. So change that to single face. Pick this one. Okay. Only this side goes out. And ideally, it's actually not a uniform degree. It's 15 degree at the point at that, and this actually goes blend really smooth here. Ideally, it should be a swept or some other things, but we can just do this. Okay, actually, let's try something else. Add a set. Pick this point, this face, try 0 degrees. No, I don't like it. Maybe 1 degrees. No, okay. We'll just do this. And F8. Now you can see the face from the top. Okay. So that's the draft. Then next is a sketch for the swept. Okay, again, we're gonna draw on XY plane. I guess you don't really have to pick a plane as long as you're looking normal to the plane, X, Y, or Z. It'll automatically create the sketch on that plane. Alright, so we have we can hide the solid because this is using the first sketch as reference. A reference line, vertical, going up, and there's a dimension there. Then we have another line that's sort of like this. Then 2 arcs. One arc is on the left side. It's got blocked here. It actually should be tangent. And you should know that most mechanical parts, if the surface connects each other, it should be tangent. You want something to be smooth. You don't want your product to be very pointy or something. Then another arc. So the center will be reference line. Those 2 on the sides are the guideline for our swept. Then here you have a point in the middle. So it's actually a midpoint constraint. That's why this way this line is centered. Then we have a dimension for the line here. It's 0.025. And also we have a dimension from this line to to the axis. So click x-axis. That'll be 3.86. And as you can see, the line on the left is constrained, the line on the right is not. So we add a dimension between them. And when I click, you notice you want to click on the outside of the arc. If you move inside, it's gonna snap to the arc center. So if you do this, that'll be far away. Okay. So it's the little things that matters. You have to click outside of the circle to pick the arc, or you can just turn it off. Turn the arc center off. Okay. So this is point 125. That's the shape we want. It needs one constraint is for the reference line. If you don't like that, trim this off. It still needs one constraint. Let's see what happens. Actually, I don't see anything. Oh, there's a point. Okay. We can delete that point. And it will lose the midpoint constraint. We'll put that back. Okay, just for the sake of fully constrained. And finish. So, before that, we have some extra things to do, and this is critical because this face, we have sharp corner here. After we make the edge blend, this top and bottom, 0.02, hit enter. Should go all the way through. If it didn't, that's because I skipped one edge blend in the slides. So if you're following the slides, 0.02, pick top and the bottom edge. It doesn't go all the way through because it's on tangent edge. You can pick those two. Okay, that's the way that slides works. Then I put another edge blend here just to look a little bit nicer. Don't have to do this. Okay, so let's see. That's not right. Should be point. Nope. So that's why I didn't put this in the slides. But let's put it like this. Okay. Then the top and the bottom. So you can tell that now it's picking up the whole edge, because this with this edge blend, this top and the bottom will be tangent curves. Okay, so the point of this edge blend is to get this surface or this cross section fillets on this cross section, because later on we're gonna have the fillets going into the swept, and it's really hard to do edge blend after you have a swept, because this is a complicated, they call that complex surface. It's hard to do edge blend. The computer can't figure out. Okay, we have 7 datums. This is the hard part, or the important part. Okay, and we have the first 2 datums are at distance from this face. Okay, we pick face from this face. Then from the 3rd to the 7th are at distance from XZ plane. Okay, so 1.4 inch, 2.1, and so on. And the last one is the end of the curve. So the first 2 you can just get a datum, inferred or at distance, same. And then type in the distance, 0.05 for first one. Then and again from the same face, 0.4 inch. Okay, so those 2 will generate. Let's go to the top. This edge. Okay, this edge should not be parallel to x-axis. This edge is actually at angle. That's why we have these 2 datums at angle. So this will form something like that. Now we need to find the slides. Okay, then the other 6 datums. Okay, datum. Now we can hide the solid, so it'll be a little bit easier to snap to pick XY plane. Then the first one is, I'm sorry, XZ plane 1.4. Apply the second one 2.1, and these dimensions, they matter. I tried different dimensions to get proper shape, so you do want to follow this, otherwise your swept is gonna be funny looking. And the last one is from here, but didn't give you the dimension here. It's actually, if you look at the sketch here, you do have a dimension. You can use that dimension, or you can simply just drag this arrow and snap to the end point of the arc. That'll give you the same distance from XZ plane. Okay, so that's for the datums. Then we have 7 datums on 7 sketches. Okay, so the first sketch is on this one. Now we're gonna start a sketch on the datum. Coordinate system doesn't matter. Show the solid. So we're going to project the curves from this face, then offset, or not offset, move this 0.025 to the left, because our data goes out a little bit to the right side, so we compensate that. And let's see, project curve. I just want, well, connected curve might work. It's actually, you can use face edges, just pick the face and it's gonna project the whole thing, but all we need is the 4 edges. So gotta be careful, you need to pick the edge. Okay, if you pick that line, it's gonna pick the whole sketch. That's your first sketch. And apply. Then we have 4 lines. You can turn them into reference, so you don't change them. And we can use profile tool someplace on the curve, starting from that, then go overshoot, and we can touch the line a little bit, see if it gives us the option to be parallel. Obviously it didn't. Then we end up on the point again on this line and close this loop. Okay, then the top line, I think it's not collinear yet, so we're gonna make them collinear. So for now on, I sort of sketch from the 3D perspective. Reason being is it's a little bit clearer than draw like this. Of course you can hide the datums, but hide 6 datums every time and show another one, too much work. Then and also this view gives you some idea of the relative position of your lines with respect to the bottom sketch. Okay, so dimension between, you can't dimension like this because this is actually not a straight line, it's a spline, as you can tell. So you can't, they don't have distance between them. So the closest thing you can do is get a distance between those 2 points vertically, 0.025, and the same goes for the bottom, 0.025. And if you want to take a look, Shift F8. Yeah, doesn't look that well. Maybe we should put a fillet first. Okay, so fillets 0.02 here. Better to just click the corner point and Okay, that's this one, this one. Alright, then dimensions. Dimension from this point to the end point. Vertical distance, horizontal distance 0.025, and same goes for this. So it's not exactly uniform distance between them. Then we have from here to here. You don't want angled, so before we do that, we make this vertical. Then distance between them is, I think we have some constraint automatically added. Just turn that, delete that, sort of another constraint, delete that. Now it works well now. 0.025. Okay, because I think it automatically add a point on this curve. So that's the reference projected curve. Will be conflict with this dimension. Anyway, so I need 3 constraints. Let's see what happens. Turn the dimension on. Yeah, I think we modified the projected curve. That's why it's moving. And there's a point, so it really doesn't matter. Finish sketch. That's for the first. The next is on this datum. Start drawing. Origin doesn't matter. If you want to, I guess you can snap to the origin. Or snap. Just leave it there. It'll automatically put this x-axis on xy plane, so it's pretty good already. Because we need those 2 points from the guideline anyway. So we need to find the intersection point of those 2 lines within this datum plane. We use intersection points, and this tool is funny. You can only do this 1 line at a time, so you have to do 1 point or 1 curve, apply, and another point. Okay. So if you notice, we have 2 little cross on the screen, and it doesn't zoom in as you zoom in. It keeps the same size, so you have to find them when you can, and turn them to reference so you can see it better. Then this sketch is actually from this view. It's a little bit off. It's not normal to the sketch. Just so you know. Then we start from this, and this time the horizontal is like this. Okay, you gotta keep that in mind. And we have a arc which is not tangent, so I'll go from that. Go up, not vertical. This should be horizontal, and another tilted line comes into horizontal distance, and now it'll be vertical. Then the last is a 3-point arc. That's the basic shape. Then we add dimensions. Dimension, first the angle is 75 degrees for this side. Then between this and the horizontal line here is 60 degrees. And let's see. We can now add vertical distance. This is 0.26. Then from top to bottom is 0.41. What we have more vertical is on the other side. This 0.11, and we do have one more horizontal distance is for this gap is 0.025. Okay, then if you notice the dashed line here, that means constraint, right? Now we're going to constrain those two lines onto this point on curve. So that's the dashed line. Then we have a radius for this arc is 0.4, and this radius does matter for the bottom surface. Yeah, let's see. This can still move because we didn't have this P68. At the bottom is 0.3. Fully constrained, then we need to add 2 fillets, which is 0.01 at the bottom on the lower corner, then 0.02 on the higher corner, and fully constrained, finish sketch. So this will be the same pattern in the next couple of sketches. So next one, and you notice it's pointing the Y downwards. We can flip that so we pretty much view from the same direction. Okay, and that was determined by the normal of your datum by default. Usually the sketch normal direction of your sketch is the same as your datum. Let's see if it's the second. Then we go page down to the third. Okay, that's the third. Now again, that's well, first step is find the intersection point. Apply for each curve, and turn them into reference for easy viewing. Then make the same pattern somewhere from here to the point. Then we'll go up 75 degrees coming horizontal, go up, don't want to snap to anything, so make this horizontal. Yeah, that's horizontal looking from this angle. Then go vertical, the last 3-point arc. Okay, and this is not horizontal yet, so make this horizontal. And again, we have point on curve constraint. So this way the right side is always aligned with this guideline. The left bottom corner is always on the other guideline. Then dimension angle is always the same, 75 and 60. Now let's see. And its height is always the same, 0.11. It's sort of like at the blade distance, and that's 0.5. Then we have another one should be at the bottom, 0.12. Then okay, 0.12. Then the radius 0.6. Then it goes up, so we can drag this line up a little bit. Control Z. Okay, you can actually hide the first couple of sketches we're done. And let's see. Okay, dimension, distance of this 0.18. Then from top to bottom, which is x-axis, is 0.41. I guess this 0.41 will be always the same. And the flick constraint, let's take a break in the video. Okay, coming back, the third sketch is done. And the finished sketch, you can hide this, hide the sketch. That'll be the fourth sketch on the datum, and changes the coordinate system, the axes. Okay, the fourth. So this time it's views from the orthogonal, the normal direction, but we still have the same procedure. First, find the intersection point and turn them to reference. If I can click on the point. Yeah, see, once you have this on, it's hard to click things. But it's also neat when you want the start center. Okay, and the same procedure. Let's see. From the bottom, go up, one step, go up, horizontal, go down, vertical, and arc. And done with this, make the bottom horizontal, makes bottom and vertical line go through this point on curve. Then did we put fillets there? We didn't put fillets there yet. Okay. Anyway, let's finish this sketch first. It's 75 degrees, 60 degrees, and we have the step, the same height, 0.11 inch. The total height, still 0.41 inch. Then this change, 0.16. And the radius of the arc is 0.4. Then what we have is this little step, 0.05, and the bottom line length 0.1, and lastly is fillets. We have 1, 2 fillets, and they are different in radius. 0.025 for the bottom lower one here. Okay, finish. Then we'll go back to the third. Okay, to add the fillets. Fillet. Then 0.2, 0.25. At least that they are the same across different sketches. Then 0.025. And this corner here. It's 0.2. Yep, we have a lot of sketches. Show them. See if we have the fillets here. We don't have it here. I still need to go back. 0.02. This actually connects to the fillet we did on the solid. So 0.02 for this corner. So 3 fillets per sketch. Gotta remember that. Then height. What else? That should be the 5th sketch on this datum. Switch Y direction. Okay. First step, intersection point. Apply. Y, and where's that? Should be here. Reference, and turn that to reference. The next is the shape. Let's start from here, and again 75 degrees one step to 60 degrees horizontal, go down vertical, then 3-point arc, then make the bottom horizontal. This should not be parallel, this should be horizontal. I think we got the shape. And D dimension is 0.11, and the bottom is 0.14. Angle here 75, angle there 60. Then this little step is 0.15. The total height to x-axis is 0.38. Then why are we still having things? Okay, this step is 0.03. Okay, needs two constraint. Okay, yeah, two constraint means this bottom line and the vertical line here goes through this point. Still need one constraint. That's for the radius of the arc. It's 0.6 inch. And we're down here. I think that should be fully constrained. This one is also fully constrained. Then Control B to hide. We have 3 sections to go. 1, 2, 3, 4, 5. So let's take a look. Show everything first. Okay, sadly we put this one on the wrong datum. Okay, so what we do here is make datum external. Yeah. Okay, we can just leave this sketch. Then what we do, can we turn this whole thing into reference? Alright. We can just simply project that sketch. Okay, this is totally not because I made a mistake. So first make a sketch on the correct data, which is the 7/6 datum, and you need to project the whole 23rd sketch 7 curves to that's not right because that's the intersection point is different. Well, this you have to go through this again. Alright, so first project intersection point, then turn to reference, then start drawing. Go up, not parallel, then this horizontal, this vertical, and there's horizontal plus 3-point arc, and bottom and vertical line goes through the point, and dimension. This is 0.11, and the bottom. Yeah, okay, we're redoing the 5th.14. Then I hope when you're watching this, you realize I was drawing on the wrong plane, that didn't make a mistake as I do. 75. Then that's the angle between. Oops. This two. 60 degrees. You should have a okay. Sometimes my keyboard is stuck. Then you can zoom. From here is 0.38, and the last one is the radius of that, 0.6. And the fillets. Yep, so we have 0.2 on the top. Sorry, 0.02 for those top two corners. It's not right. Just make sure you click on the intersection point. Then 0.025, or this time we change 0.015 for this corner, because it's getting to the smaller region. Fully constrained, finish sketch. Then we have 2 sketches to go. Yeah, it's still the same thing. Okay. It's still pretty boring. And intersection point. I hope you use YouTube and speed up in the play option for the video. Go up. Let's see, horizontal, that angle. Oops. Oh, didn't get horizontal on that. Vertical. Then this is horizontal. 3-point arc. Then we get that back to horizontal. Those two should go all through the point. Then dimension 0.11. Yeah, we should go down one page. Yep, 0.11, and the bottom line is 0.15. 0.15. Then this vertical line is, let's see, 0.24, right? Okay. This dimension, 0.24 is all the way to the bottom, so this is 0.14. 0.14, 24 from the top to the bottom. 0.24, and we have this gap here is 0.01. It's really getting too narrow place. 70 degrees. Zoom in and find that 60 degrees. And the last one, this one. Radius is 0.2. And the real last is fillets. And do we have anything here? Yeah, we have a really small fillets here, which is 0.005, and fully constrained. The sketch is done. Now we have the last one, almost there. So last one, sketch on this. Switch the y-axis pointing up, and it's easier than other things, so probably don't snap to anything just yet. Then dimension from point to y, 0.02, and the top is 0.01, height 0.1, and 75 degrees, don't forget that. 75 degrees, and the bottom apparently should sit on x-axis, and I think it's fully constrained, but don't forget fillets 0.02, okay, for this corner. Finish sketch. Now let's hide the data. That's all the sections. Now we need a starter guide, okay, which is this plane, XZ plane. Then first straight line from the fourth from the little side. So top of this, just straight line, snap to the top, go over the axis, then the other side, 3-point arc, same point, and this point, make a tangent here. Bear in mind that guide curve always has to be tangent. So you can see pretty much the frame here. Okay. So as we said before, the swept has 8 sections, out of which 7 are sketch, and the first one is actually the plane on the solid. So swept curve, connected curve for this one, very first, you can use face edges. That'll give us this. And let's try to specify the origin curve the same way, okay? Then we change to connected curve. Now we need to click on the same position of a sketch so they align together for the origin curve. Yeah, another one. Hopefully this will come out nice, but pretty much sure you have to do a manual by point alignment. So now it's the curve, the guide curve. First one looks ugly. Then new set. Second one, a little bit better. Then we can add the third, which is right here, and say, take a look at the alignments. It doesn't align well Okay, of course, because the sketch is too complicated. So we can use bipoints here. Now this is the hard work. This is the headache here. So you need to align this point from the bottom of your first two. Okay, and for this alignment here, there's really no good way to tell where. Just eyeball it, sort of in the middle. And okay, that looks fine. Then for this side, the only difference, we want to make this all the way up, so you have a nice curve at the bottom. So we're just adjusting the alignment points, the key points, and this edge, you want to make this point go up to the end point of the fillet. Also this point too. So they line smoothly with that, and we can move this a little bit higher. So this is really aesthetic, and I understand this is pretty complicated. If you have hard time doing this for the homework, you really don't have to make it 100% perfect. Okay. So here we can put those 2 points in the midpoint, around midpoint on the fillets. Really depends what you want. Then for this edge, it will go nice along this edge. And I think we need a point on the top for those top lines. So we can add a point here. If you click, it'll add another point. You can drag that new point, so you have more control points. So notice I wait to see the snapping point, so I know where this point goes exactly. And looking here, we want this go down, top stays on the top. Okay, and we can adjust this curve a little bit to see the curvature looks natural or not on this side. Then what about this align point? Okay, so this point, you can move this thing a little bit. And honestly, this is our aesthetic, as long as this whole piece looks nice. Let's do a fit. Where's my fit? Okay. We can do okay first, so you save the swept, otherwise you adjust for a long time and then just lose it. That's painful. So we can make this go down to the fillets. Then what about this side? Now this point. Okay, so now this point goes into the which side? Let's see. We can make that go to the bottom and take a look at the surface, and we can also hide the sketches. Okay, so it's a little bit, this point, you can move this point a little bit out, or change the sketch to make this a nice arc. So for now, I'm happy with the results. Okay, look at that. It's actually pretty close to the real thing we have, except the tip a little bit. So next step, we need to make an edge blend here. This one is really this one is needed because you don't want that sharp corner here. So pick the edge, not everything, so not tangent. Deselect. We want a single curve from here to the bottom. Then we have to pick this as well. Well, the thing is we need to merge those two first, right? Those two solid. Otherwise, the edge blend just goes right into the piece. So we're gonna unite those two pieces. Then edge blend. Okay. So now it's different now. We can pick the top and pick the bottom, the fillet edge. Then what's the radius on that? Adjust to make it big, and as long as it doesn't complain. Okay, so maybe 0.1 inch. See what we have here. It's 0.08. You can have 0.1 inch. That's fine. And that concludes this model. So yeah, the swept is a little bit complicated, and actually this face 0.11 inch always is the sort of like a blade in the blade. Then that flat face at the bottom that goes to the other blades. They match each other. So that's all for this lab. I think it's pretty long. I hope you can get a good model out of this.